OCI, Orange County Inspections, is glad to present the following: the Quality Control and Quality Assurance Professional Seminar, segment number 9. The topic of this segment is the WPS, and the items that will be covered are the Pre-Qualified WPS. We will see how important it is for you, the quality control and quality assurance professional, to understand the term of pre-qualified. The D11 code utilizes the idea of pre-qualified weld joints, and by following a number of well-defined variables, the user of the pre-qualified WPS does not have to qualify the procedure. Next is the requirements and limitations of a well unknown part of the D11 code, and that is the Annex Q that covers the contents of a pre-qualified WPS. This annex is not part of the D11 code, but is provided for informational purposes only by the American Welding Society. We then take a look at the WPS qualified by testing. Now this is where the PQR we just reviewed in the previous segment comes into play, and remember, the PQR establishes the WPS. And the last item is the essential variable table for when CVN, also known as Sharpie V-notch testing, is required with the WPS. Before we get started with the items of this segment, let's make sure we understand the basics, and with the WPS we must ask, what is a WPS? First thing is, what does the letters WPS stand for? They stand for Welding Procedure Specifications. Then second question is, why is a WPS used? And to keep it very simple, think of it like a cooking recipe, where it tells you how to weld a joint assembly plus also the required testing. And the third thing is that there are two types of WPSs to be aware of: the pre-qualified WPS and the WPS qualified by testing. Let's start with the pre-qualified WPS. And first, you must grasp this is a system that is exclusive in the welding industry, due to the fact that the American Welding Society has many procedures which are considered pre-qualified. Now, with the term pre-qualified, there is no need to perform a qualification test as long as the welding parameters are within the certain prescribed limitations. So now let's review the list of items that, when used in a precise combination, will be measured pre-qualified. The first recognized item on the list is welding process. The D11 code labels 4 processes: shielded metal arc welding, flux core arc welding, gas metal arc welding, and submerged arc welding as pre-qualified, which means there is no need to test a weld joint assembly if these processes are followed as per the manufacturer recommendations. Next item is the base metal, which is a lot like the welding process, in which there are many acceptable base metal groups within the D11 code that don't require qualification testing. The third item is the material thickness, and here the value of the welding procedure could be affected by the different introduced thicknesses, and that is why the pre-qualified weld joints listed in the D11 code have limitations on the thickness ranging from 1/8 of an inch and greater. Now is the joint configuration item, which is a sketch that provides table-like values for the accurate requirements covering the process, thickness, and position. The table covers other items as the root opening, groove angle, and their tolerances for both as detailed and as fit up. And last are the welding techniques, which include the means used to prepare the joints, as well as the extent of weld surface roughness, cleaning each individual weld bead, also including any oxygen cutting, air carbon arc, or maybe some form of grinding shall be specified for the production work. Here's an actual pre-qualified WPS. Once again, provided by the American Welding Society for our educational purposes, and the first thing, it's basically the same as the PQR we saw in the last segment. But there are a few items that make this a pre-qualified WPS. The two most important items that establish a pre-qualified WPS are the box being marked as a WPS and the marking on the pre-qualified line. As we cover the rest of the form, it will be a lot like the PQR first page. With this first box containing the company's name, welding process, and you see the word pre-qualified on this line for supporting PQR. Second box is the joint design used, with items like type of joint, single or double weld, backing information, joint configuration, and back gouging if applicable. Let's stop here and understand something. This information should be within the pre-qualified joint assemblies established by the D11, and if out of the tolerance allowed, it would be deemed not a pre-qualified WPS and would need a PQR to back it up. Does that make sense? Third box here covers the base metal information like specification, grade, thickness, and any pipe dimensions if used. Moving to the fourth box is the information for filler metals and shielding of the filler metal if applicable. And with the filler metals area, it states the specifications and the classifications, while the shielding area is looking to provide the type of flux and mixture amounts of gas used. Found in the fifth box is the pre- and post-heat information with items like minimum and maximum temperatures for the base metal and weld beads are shown, while also establishing the rate of cool down with the time frame. Move to the top right of the form, we find a box with identification number for this WPS, revision numbers if applicable, date and by whom created this WPS, plus the authorization and date for reviewing this WPS at creation time, and look closely with information about the type of weld being used, whether manual, semi-automatic, mechanized, or automatic. Next box down covers the position for both groove or fillet weld and the progression of the electrode, whether up or down hand. We see the box covering both the electrical characteristics and technique used that exposes items such as the current, power source, transfer mode, information needed for the tip used with gas tungsten arc welding, and also are string or weave beads being used, and the number, position, and spacing of multi-electrode, if applicable, plus contact tube distance from workpiece to any tooling of the weld bead and cleaning method of the individual passes. And next is the area that provides large amounts of information for the WPS, and that is the welding procedure. With this box, you will be cross-referencing the information found here with the line items above, and remember they must match or this is a non-conforming WPS. The first column notes how many passes are found in the actual weld joint. Second column states the welding process, which should match the line item above under the company name. The next two columns come under the filler metals, which provides the classification and diameter of the electrode. So now the classification should match the item stated on the line above found in this form. We come across two more columns falling under the current used, which are the polarity and amps, And once again, these should match the line items above. Following the current column is the volts column. Then comes the travel speed column, which equals the amount of inches it will take the welder to weld a pass in a minute. And lastly is what the weld joint will actually look like, and you should be able to find this joint detail in the D11 code by using the pre-qualified joint designation number found on the type of joint line item above, and also the number of passes and their placement within the joint should match the column found back on the far left of this box. And remember, the information stated here should match both the AWS D11 code and manufacturer requirements. If not, this is not a pre-qualified WPS and will need a PQR to establish its compliance. Second item we will cover in this segment is the requirements and limitations that are provided by the American Welding Society for our convenience, which is the Annex Q, contents of a pre-qualified WPS. When using a so-called pre-qualified WPS, this annex must be followed or it will make a qualification. This annex must be followed or will make a qualification test by a PQR needed. Here we see the actual Annex Q, and we will focus on this area. You find two sections to this annex. One is the actual line items that require information based on the established material from the D11 or manufacturer. Next section are the code sections that must be followed or the pre-qualified WPS will not be in compliance and will need to be established by a PQR. Let's view how this annex works. We will take a look at slot ends, and you might say that you don't remember a line item for slot ends on the form we just reviewed. And yes, you would be correct, but this annex must be followed, and the code states exactly what the requirements for slot ends will be. And here's the actual code section for slot ends. You see there is an established radius equation that must be met for compliance. Okay, next we look at backing. And here is a code section covering backing, but slow down and realize there are many subsections covering backing. Yes, you have the general opening paragraph, but here is the section covering fusion, then full length requirements of the backing. Up in this corner is the backing material thickness for each weld process. Next is a section for cyclically loaded non-tubular connections. And here is a section for externally attached backing. And we close the section covering backing with the section for statically loaded connections. So as we close this item, we hope you see there are steps to having a complying pre-qualified WPS. The form must be marked properly. Then Annex Q must be reviewed throughout the production work for any changes. We move into the third item of this segment, which is the WPS qualified by testing. So to help you understand this better, the AWS D11 utilizes the means of pre-qualified weld joints, and by following a number of clear variables, Annex Q, the consumer of the pre-qualified WPS does not have to qualify the procedure. Qualification is required only if any of the variables are changed beyond their specified limits provided within Annex Q, and when that happens, the need for a WPS qualified by testing is required. You see here the form, which is identical to the PQR and pre-qualified WPS forms we have reviewed earlier. Here's the two items that establish the WPS qualified by testing: the marking of WPS and qualified by testing line items. Next, we see the box that covers items like company name, well process used, date and authorization personnel. This first arrow covers the joint design used, like type and dimensions of the joint. The second arrow covers base metals with items of specification, thickness, and pipe diameter if used. Here with the third arrow are filler metals that state specification and classification. Next, the fourth arrow contains the shielding of the filler metal with needed information in flux and gas mixture used. And lastly, on this side of the form is the fifth arrow, showing the preheat area that reveals the minimum and maximum temperatures for both the plate and weld beads. Moving to the top right of the form is the sixth arrow, which covers the position of the groove or fillet weld. The seventh arrow establishes the electrical characteristics of the WPS with items like the transfer mode, power source, and size of the tungsten tip used. Now we see the eighth arrow covering the technique used. It states the type of bead, number of electrodes, and if cleaning of passes is required. And to finish the line item is the post heat, which states the temperature and time used for the method. We come to the welding procedure box, which states the actual variables used for each individual passes, plus the diagram of the actual weld joint assembly. As you see, all three methods, the PQR, the pre-qualified WPS, and the WPS qualified by testing, document the how-to of welding the assembly, plus are identical within the required line information, but are different in meanings by just the markings found in the form header. And to close the segment is the fourth item, the essential variable table. And yes, this looks a lot like the PQR essential variable table we reviewed in the last segment of this seminar. But with this table, it's used when a CVN, or also known as Sharpie V-notch test, is required. Before we look at the table closer, let's review what the Sharpie V-notch test is all about. Also called the Sharpie impact test, this destructive test reveals the amount of energy absorbed by the weld joint material during fracturing. This absorbed energy measures the weld joint material notch toughness. Here is a diagram of the equipment and the test specimen used in the Sharpie V-notch test, which consists of a pendulum that is dropped to impact and break the pre-notch weld specimen. The value, called breaking energy, is the primary information gathered from the test, which is expressed in terms of foot-pounds of energy. Now we understand the Sharpie V-notch test better, let's look at the table. This table has two parts, with the first part, which lists the variables to be reviewed as the work is in progress, and within this part we find the categories of the following: base metal, filler metal, position, preheat inner pass temperature, post-weld heat treatment, electrical characteristics, and other variables. The second part of the table identifies what is applicable to the variables. Here are the covered welding processes. And we are familiar with the X marking that reveals this variable is applicable with the process it's found under. And also, when there is no marking and just a blank box, it means it's not applicable. Okay, we will take a look at how to use and understand the table. First, we look at variable line item number 1, which states any change in group number for the base metal shall require the WPS to be requalified, and if using all the welding processes shown by the X markings. Next is variable line item number 6, which covers a welding progression change to vertical unless the WPS was using the 3G position already. And we see all processes are applicable except for the submerged arc welding process. Then lastly is number 10, which covers a change from a stringer to weave technique. And we see all the weld processes are applicable to this variable line item. So we see that this table uses the same steps to find the correct answer, which will allow you, the quality control and quality assurance professional, to observe that the production work is staying in compliance with the applicable codes and specifications. We have come to the end of the segment, and let's review the items we covered. First, we alerted you to the fact there are 2 different types of WPSs, and the most often, or should we say the most tried in the industry, is the pre-qualified WPS. You see that all the line items on the pre-qualified WPS must match and meet the minimum of the applicable codes and manufacturer's recommendations. Second, staying with the pre-qualified WPS theme, we presented to you the contents of a WPS found in Annex Q. And these code section items must be in compliance throughout the production of work, or the pre-qualified WPS must be tested to establish compliance with the applicable code and specifications by ways of a PQR. Then we saw the second type of WPS, which is qualified by testing, the PQR. And as with the pre-qualified WPS, the variable line items must be followed to keep compliance. And lastly, we took a look at another essential variable table that is used when the Sharpie V-notch test is required, and as the PQR, these tables state certain variables that must be observed again throughout the production work, and if any changes occur, the WPS must be requalified. The study material for this segment will include reading the following destructive testing guides. The first guide is written by G-Tech, which covers the Sharpie V-notch testing. Then the guide for bend testing, written by Northern Westmoreland. And you finish with ASM International Guide about tensile testing. If any questions arise, email orangecountyinspections@yahoo.com. When completed, move to segment number 10.